In today's video, we are going to make a comparison between two refrigerant gases with serious ecological issues. We're talking about R404A and R22. R22 destroys the ozone layer and has a global warming potential, GWP, of 1760, while R404A does not deplete the ozone layer, but has a GWP of 3922. 22 South African Rand is a pure refrigerant, meaning it is composed of a single gas. On the other hand, R404A is internally formed by a mixture of several gases. R22 is used in various fields, including air conditioning, refrigeration, and freezing, while R404A is mainly used for freezing, and with less efficiency in refrigeration. It is not used in air conditioning. Both R22 and R404A are non-toxic and non-flammable. In the case of R22, it is possible to recharge it in both liquid and gaseous phases, without any problem, due to its nature as a pure refrigerant. However, R404A, being a gas mixture, must always be recharged in liquid phase. This is an important consideration to take into account when performing maintenance on refrigeration systems. Furthermore, it's interesting to know the internal composition of R404A. This refrigerant contains approximately 4% R134A, 44% R125 gas, and 52% R32. Another significant difference between the two gases is their compatibility with different types of oil. 22 South African Rand is compatible with mineral oil and alkylbenzene, but not with PO oil. On the other hand, the refrigerant gas R404A is only compatible with PO oil. Although R404A and R22 have similar cooling performance, there are still many differences between them in real-world use. The saturation pressures of R404A and R22 are different at the same temperature, making them not interchangeable. Replacing R22 with R404A leads to problems with the operation of the expansion valve, pressure control, lubrication, accumulators, separators, and refrigerant gas flow. Furthermore, since the density of R404A gas is approximately 50% higher than that of R22, when using R404A, the pipe diameter needs to be larger for the same displacement. Let's compare the measurements of the capillary tube for both refrigerant gases under the same operating condition. For the same compressor, the current required for R404A is higher than that for R22. Now, let's study in detail the pressures of each of these refrigerant gases and their impact on refrigeration systems.
The most used R404A refrigerant gas pressures are 1. To reach a temperature of -20 degrees Celsius in the evaporator, equivalent to -4 degrees Fahrenheit, a low gauge pressure of 2.1 bar is needed, equivalent to 29.55 psi-G. 2. To achieve a temperature of -15 degrees Celsius in the evaporator, equivalent to 5 degrees Fahrenheit, a low gauge pressure of 2.62 bars equivalent to 38.51 psi-G is needed. To reach a temperature of -10 degrees Celsius in the evaporator, equivalent to 14 degrees Fahrenheit, a low gauge pressure of 3.32 bars is needed, equivalent to 48.80 psi-G. 4. To reach a temperature of -5 degrees Celsius in the evaporator, equivalent to 23 degrees Fahrenheit, a low gauge pressure of 4.11 bar is needed, equivalent to 60.42 psi-G. To reach a temperature of 0 degrees Celsius in the evaporator, equivalent to 32 degrees Fahrenheit, a low gauge pressure of 5.1 bar is needed, equivalent to 73.65 psi-G. 6. To reach a temperature of 5 degrees C in the evaporator, equivalent to 41 degree F, a low gauge pressure of 6.3 bars is needed, equivalent to 88.64 psig. In some cases, it is useful to know the pressure of the equipment when it is turned off and the high pressure or the condenser. Let's see them. 1. For an outdoor environment temperature of 25 degrees Celsius, about 77 degrees Fahrenheit, the equipment turned off, with this temperature, has a gauge pressure, both high and low, according to the table of 11.40 bar, equivalent to 167.58 psg. 2. For an outdoor environment temperature of 25 degrees Celsius, such as the condenser temperature, it is usually about 10 degrees Celsius, above the environment where the equipment is located. Thus in the table, for 35 degrees Celsius, about 95 degrees Fahrenheit. The high gauge pressure in the condenser is 15.1 bar, equivalent to 251.8 psig. We can say that it is a refrigerant that handles medium pressures. Let's start analyzing the most used pressures. 1. Low temperature system, freezing to minus 20.5 degrees Celsius, approximately minus 5 degrees Fahrenheit. If we look in the table to reach this temperature in the evaporator, we need that when the equipment is turned on, it marks a pressure on the low manometer of approximately 20.1 psi. This value is equivalent to 1.3 bars. 2. Average temperature system freezing to minus 9.4 degrees Celsius, about 15 degrees Fahrenheit. If we look in the table to reach this temperature in the evaporator, we need that when the equipment is turned on, it marks a pressure on the low manometer of approximately 37.8 psi. This value is equivalent to 2.5 bars. 3. High temperature system, refrigeration without freezing or air conditioning equipment. In this case we are going to have a temperature of 4.4 degrees Celsius, approximately 40 degrees Fahrenheit. If we look in the table to reach this temperature in the evaporator, we need that when the equipment is turned on, it marks a pressure on the low manometer of approximately 68.5 psi. This value is equivalent to 4.6 bars. 4. Now we are going to look for the high blood pressure in the table. For this we are going to take as an example, an external environmental temperature of 30 degrees Celsius. We increase this value by 10 degrees Celsius and look in the table for a pressure value for approximately 40 degrees Celsius. Thus we have in the table, a pressure of approximately 211 psi. This value is equivalent to 14 bar. 5. Another pressure value that is usually important is the pressure of the equipment when it is turned off. In this case, for the same room temperature, we look directly in the table for an approximate value of 30 degrees Celsius and we obtain a pressure value of about 156 psi.